Hey everyone, welcome to this explainer. I am so thrilled you're here today because, well, we're going to completely dismantle everything you thought you knew about building secure login systems. Seriously, if you've ever felt frustrated by a website forcing you to add a capital letter, a number, and some random symbol to your password, you are in exactly the right place. Today, we're tearing down those outdated security habits and rebuilding our authentication systems from the ground up, relying strictly on the latest evidence-based standards.
Okay, let's dive right into this with a number that should make every developer and system architect literally sit up straight. 81%. That is the staggering chunk of hacking-related breaches that involve weak or stolen passwords. It's consistently the #1 attack vector year after year. And when those defenses fail, it's not just a minor headache. The average cost of a breach involving compromised credentials currently sits at a massive $4.45 million. Even if you're using multi-factor authentication, passwords are the front door. If the lock on that door is fundamentally broken, absolutely everything inside is at risk.
Consider this our structured developer syllabus for the day. First, the password paradox. Then, NIST's new golden rules, blocking breached passwords, secure password storage, the developer playbook, and finally, embracing password managers.
All right, kicking things off with Section 1, the password paradox.
For decades, we've forced users into these wild complex rules, right? Which honestly just led to sticky notes on monitors or, password 123 with a capital P. And this brilliantly illustrates exactly why those old rules completely fail. Take a classic complex password, Trobe 4-door and 3. It's got the uppercase, the lowercase, the number, the symbol, the whole shebang. But mathematically, it only has about 28 bits of entropy. It is an absolute nightmare for a human to remember, but it's actually trivial for a modern computer to guess. Now, compare that to a phrase password. Correct, horse, battery, staple. 4 random common words. It has 44 bits of entropy. That is orders of magnitude mathematically harder to crack, yet vastly easier for a human being to memorize. The science is in, folks. Length beats complexity every single time. Because length beats complexity, we really need to systematically eliminate the bad habits we've baked into our forms over the years. Here is what you literally must stop doing immediately. Stop forcing character composition rules. No more requiring special symbols. Stop using password hints. Actually, let's be real. They're just a backdoor for social engineering. Get rid of knowledge-based authentication, like mother's maiden name, because that info, it's public record now. Stop relying on SMS-only second factors due to SIM swapping vulnerabilities. And crucially, stop enforcing arbitrary 90-day password resets. When you force a user to change their password every 90 days, they just take their existing weak password and change the 1 at the end to a 2. It actively harms your security posture. Moving on to Section 2, NIST's new golden rules. So the National Institute of Standards and Technology actually completely rewrote their digital identity guidelines in a document called Special Publication 800-63B. This is the modern, evidence-based standard we've been waiting for. The rules for user-chosen passwords are incredibly straightforward now. Set a minimum of 8 characters, allow a maximum of at least 64 characters to support those long passphrases we just talked about, accept all printable ASCII and Unicode characters. That means spaces are allowed, emojis are allowed. Seriously, do not be the developer who blocks an emoji. And finally, no composition rules. Your goal as a developer is to accommodate length seamlessly, not to force unnatural character combinations. Which brings us to Section 3, blocking breached passwords. You can't just check if a password is long enough anymore. You have to make sure it isn't already breached. But, how do you check a user's password against a database of stolen passwords without accidentally exposing it over the internet? Well, you use something called a K-anonymity model, which was famously implemented by the Have I Been Pwned API. It's this absolutely brilliant piece of cryptography that acts like a simple slice and check recipe. Step 1, you hash the user's proposed password with SHA-1. Step 2, you take just the first 5 characters of that hash and send it to the API. Step 3, the API returns a massive list of all breached hashes that happen to start with those exact same 5 characters. And step 4, you compare the rest of your user's hash against that list locally on your server. The full hash never leaves your system, but you still guarantee the password hasn't been compromised. It's elegant, it's lightning fast, and it is a non-negotiable standard for modern apps.
All right, Section 4, secure password storage.
Before we even look at the math here, let's establish a golden rule. Never, ever store passwords in plain text and never let them slip into your application log files. So the crucial point is how we transform those passwords for storage. You must use a one-way hash with a unique, randomly generated salt. But, and this is a big but, not all hashes are created equal. Think about the algorithms we have available. We have fast hashes like MD5 and SHA-256. Do not use these for passwords. They are general-purpose hashes designed to be incredibly fast. When a hacker gets your database, they'll just spin up GPU clusters to guess billions of those fast hashes every single second. Instead, you've got to use memory hard hashes, things like bcrypt, argon2ID, script, or pbkdf2. These are intentionally designed to be slow and computationally expensive, which absolutely cripples an attacker's ability to brute force your database.
Now for the tactical stuff. Section 5, the developer playbook.
Beyond just the password field itself, your authentication endpoints are the most heavily attacked features in your entire architecture. To defend those pathways, you absolutely need progressive rate limiting. It's not just about stopping a brute force attack, it's about making the attack economically unviable for the hacker. Here is a highly effective timeline you can implement today. After 5 failed attempts, trigger a 1-minute lockout. If they hit 10 failed attempts, escalate that to a 15-minute lockout. At 20 attempts, lock the whole thing down for an hour. And listen, you must track these failures across 2 dimensions, per account and per IP address. This dual tracking is what stops botnets from distributing their guesses across thousands of IP addresses just to bypass your security. And while you're rejecting those bad logins, please heed this quote. Always say invalid username or password. Differentiated error messages are an enumeration goldmine. Never tell the user, or more importantly, the attacker, which half of the equation was wrong. If your system says password incorrect, well, you've just confirmed to the attacker that the username definitely exists in your system. They will take that valid username and attack it relentlessly. Keep your error messages perfectly generic.
And that exact same logic applies to the password reset flow. When a user requests a reset, always display a generic message like, if an account exists, a link has been sent. Under the hood, your architecture there must be rock solid. Generate those reset tokens using cryptographically secure random generators. Seriously, do not rely on standard math.random functions here. Give those tokens a strict 15 to 30-minute expiration window. Enforce that they are strictly single use. And finally, the moment a password is successfully changed, you must immediately invalidate all other active sessions. If a hacker is currently logged in on another device, changing the password should instantly kick them out.
And finally, Section 6, embracing password managers. You know, as developers, we spend so much time building walls that we sometimes accidentally block the very tools trying to help our users stay safe. Please do not fight password managers. They are your greatest allies in the fight against credential reuse. First off, never disable the paste function on a password field. Blocking paste is an aggressive anti-pattern. Think about it. If a user can't paste a 30-character generated password from their manager, what are they going to do? They'll just type in a weak, memorable password instead. Keep your HTML autofill attributes properly configured so managers can easily detect the fields. And as we discussed earlier, support long maximum character lengths so users aren't artificially restricted from using those highly secure generated passphrases.
So, I want to leave you with this provocative final thought, a real challenge for you to take back to your teams. Are your app's password rules actually helping the hackers? Because if you're still forcing 90-day resets, demanding special characters, limiting lengths, or using fast hashes, the answer is unfortunately yes. But the good news? The data is clear and the NIST guidelines give us the exact blueprint we need to fix it. It is time to audit your systems, drop the arbitrary complexities, and start rebuilding authentication the right way. Thank you so much for joining me for this explainer. Now go out there and secure those logins.